Respected faculty and my fellow classmates, along with all the audiences, Assalamu alaikum. This is Farhat Binte Shahid, along with my other teammates, will be presenting today the implementation of an adaptive Wiener filter to remove noise from a sound wave using Python. So, if we look into the contents, then firstly we will introduce what adaptive Wiener filter is, then we will see the objectives of this presentation, and we'll look into some block diagrams, and then we'll see the code and the outputs, both with the noises, the sounds, and the graphs. And then we'll discuss about the advantages, disadvantages, applications, and we'll conclude our presentation with this summary. So if we look for the introduction, then firstly we'll say that audio signals often suffer from unwanted noises. So noise degrades sound quality and can affect analysis or usability. So digital filters are used to enhance or restore audio. So adaptive filter is used here for audio noise reduction using Python and standard signal processing libraries. So what is adaptive filter? A Wiener filter minimizes the mean square error between the estimated and original signals. We assume signals and noise are stationary random processes with known spectacular characteristics. An adaptive Wiener filter adjusts dynamically to verifying signal statistics, so well suited for non-stationary noisy environments. Now, if we look into the objectives, then our first objective is to implement an adaptive Wiener filter using Python to denoise an audio signal, and then to compare the original noise and filtered noise signals visually, and then to explore the filter's performance using waveform plots and spectrograms as well. So if we see the block diagrams, then firstly we will add a noise to a signal, where signal is Sn and noise is Nn, and then by the Wiener filter we will filter out the noise, and then if we minus the yn from the dn, then we will get our desired signal again. So from next, my next teammate will be presenting. Thank you.
Hello, this is Jahangir Alam. Assalamu alaikum. We have implemented our code in Python. At first, we require some library for NumPy for basic numerical functionalities, matplotlib for plotting the sound file. Okay, the sound file for working with sound file, and sound device for playing the sound file. Okay, at first we create a sine wave, a simple sine wave. After that, we create a random noise. Combining both of them, we get the noisy sound. Okay, after that, we have implemented adaptive filtering algorithm. Here we use 25 iteration and tap size equal to 5. So after iteration, we get the estimated noise output, which is yn, and the filter sound, which is en. So after that, we plot all the signals. Okay, now I am sharing the real-time implementation. Here is the Visual Studio code in my local machine. I playing the code sequentially. So you hear, this is my clean sound. And this was my noisy random noise. And that was my noisy sound. So I have so this is the algorithm which takes up to 30 seconds. Okay. So here is our estimated noise output yn. Okay, before playing the filter sound, I like to play the noisy sound again. Okay, now we are playing the filter sound. For clarity, we can play it again, the noisy sound and the filter sound. Okay, after plotting all of the signal, we get the graphs. Okay, I am going back to the presentation slides. Okay, if we see the graph, this is our clean signal and this is our input noise. This is noisy sound and this is estimated noise output after filtering. So after subtracting the estimated noise output from the desired signal, we get the filter sound, EN, which is quite similar to the original clean sound, but there is still some noise is present. So it can be optimized by increasing the number of tap size or iteration. So it can be tuned. Okay, next part will be presented by my next presenter.
Thank you, Jahangir bhai. This is Fuad Hasan. I will continue from here. The advantages. Simple implementation available in standard library with low computational complexity. Already Jahangir bhai shows that there are some library in Python that can help us to build the application. Minimize mean-square errors, effective moderate noise, adaptive behavior, non-prior training needed. So basically, we don't need any test data for testing this. We usually input a signal, clean signal, then add noise signal, and with some testing, we can generate our output. The disadvantages are assume non-signal and noise statistics, Windows size sensitivity, may smooth out useful signal feature, less effective for non-Gaussian or non-stationary noise, limited real-time capability. So while efficient, real-time streaming still require optimization. So there is an important fact that we need to focus on that part. Applications are speech enhancements in medical sector, biomedical signal processing, hearing aids, forensics and surveillance, audio restoration, processing in AI systems, and the conclusions part is Wiener filters are effective for basic audio denoising tasks. Python provides accessible tools for signal processing. Adaptive filter adjust OL to dynamic noise environment. Further improvement possible through hybrid and AI-driven approach. This is the full visual code run on our local machine, and the code is also running in Visual Studio. So thank you everyone, and thank you sir for this opportunity.